everyone. Today I'll be presenting a question from KMPH. 3A. The superchiasmatic nucleus SCN is a bilateral structure used as the central pacemaker of the circadian timing system and regulates most circadian rhythms in the body. Two possible Lewis structures of SCN are given below. This is structure 1 and this is structure 2. 1. Show formal charges of each atom of structure 1 and 2. So for structure 1, we can write down the electronic configuration of each atom and then underline the valence electrons. We can also write down here for the structure so that we can label the formal charge easier. So how do we calculate the formal charge? We can refer it to here. So formal charge of an atom in Lewis structure equals to the total number of valence electron in the free atom minus the total number of lone pair electrons plus 1/2 of the total number of bonding electrons. So for sulfur, S, there are 6 valence electrons minus in bracket there are 6 lone pair 1, 2, 3, 4, 5, 6 plus 1/2 of bonding electrons, so 1 and 2 equal, and then close bracket, equals to -1. For carbon C, there are 4 valence electrons minus bracket, there are no lone pairs, 0, plus with 1/2 of bonding electrons, there are 1, 2, 3, 4, 5, 6, 7, 8. Close bracket, and equals to 0. For nitrogen N, there are 5 valence electrons minus bracket, there are 2 lone pairs, there are 2 lone pair electrons, plus with 1/2 of bonding electrons, so there are 1, 2, 3, 4, 5, 6, and then close bracket equals to 0. Then we can label it over here. So because S is -1, negative on top of S, -1, C is 0, C 0, and then N is also equals to 0 and 0. So this is structure 2. For structure 2 as well, we can do the same, like list down the electronic configuration and draw the Lewis structure first. And then we calculate the formal charge as well. So for following this, so S has 6 valence electrons minus in bracket, there are 4 lone pairs, 1, 2, 3, 4, and then there are plus together 1/2 of bonding pair, so 1 bonding pair electrons, so 1, 2, 3, 4, 4 equals to 0. For carbon, there are 4 valence electrons minus in bracket, there are 0 lone pair electrons, so 0, plus 1/2 of bonding pair electrons, so 1, 2, 3, 4, 5, 6, 7, 8 equals to 0. And then for N, there are 5 valence electrons minus in bracket, there are 4 lone pair electrons, 1, 2, 3, 4, plus 1/2 the bonding pair electrons, so 1, 2, 3, 4 equals to -1. So on the structure, we can label on top of S 0, on carbon also 0, and then on nitrogen N will be -1. For the second question, it asks for determine the possible structure and then explain. So the most possible structure will be structure 2. Why? Because the negative formal charge, which is -1, is for more like electronegative atom N. Remember, there are top 3 most electronegative atom, which are phone, F for fluorine, O for oxygen, N for nitrogen. So in this case, N. So this is more plausible. B. Illustrate the hybridization process of ozone, O3, and determine its molecular shape. draw and label the overlapping of the orbital. So for starting, we can write down the electronic configuration of oxygen. Oxygen has 8 electrons, so 1s2, 2s2, and 2p4. And then we have to draw the Lewis structure first. So there are in ozone there are 3 oxygen, so 3 times 6, the valence number of valence, equals to 18. So there are 18 total electrons. Minus 4 for the initial bonding, and then it will get 14. And then minus again 6. So for each of them, so over here, 1, 2, 3, 4, 5, 6. And then you will get, there's 8 more. Again, minus 6, 1, 2, 3, 4, 5, 6. And then you get 2. The 2 here will be the lone pair electrons for the center atom. Over here, it is advised for instead of only single bonds, we bring like the 6, like there are 6 here, right, before. So we bring the 2 lone pair electrons into a bonding pair here. So then the number of bonding pair, there are 2, 1, and 2. Number of lone pair, there is 1. And then the number of electron pair is the number of bonding pair plus with the lone pair, which is equal to 3. So the electron pair arrangement, AB3, and then it is trigonal planar. For the molecular geometry, it will be a bit different because there is a 1 lone pair. So it becomes AB2E, and the shape will become bent or V shape. So it will become like this, like a V shape. And then the bond angle will be less than 120 degrees. The type of hybrid is sp2. So now we have to draw the hybridization process. So we can split it into two, the central atoms and also the terminal atoms. Central is in the middle, which is the O. We have to, remember that in the Lewis structure, you have to label O, 1, 2, and 3. 1, 2, and 3. This will be easier for us to refer here, to write it here and refer which one are the ones we are referring to. It will be much more easier since all of them have different formal charge. For example, this one has 6 valence electrons, and all 6 of them, there are 6. So 6 minus 6, there are 6 electrons touching its body. So there 6 minus 6 equals to 0. Over here, there are only 5 for plus 1, and over here there are 7, which is more than its valence electrons, so minus 1. So for the central atom, ground state of oxygen 1, positive, the central, is the initial will be there are 2 boxes, so 2s and 2p. So this one filled, and then this one filled, this one is half filled. For the excited electron, it will remain the same as the ground state. And then the hybrid state, only one of them will come and join the 2s and become 2sp2, whereas one of them will become hybridized to b. And then the terminal atom, ground state of O2. So there's no charge, so we are referring to here. And it has the same it has the same way of writing as the ground state just now. Whereas for ground state of O3, there is a negative, so there will be an extra atom here. So this is how it will be. It will be in a bend shape, so over here has to be bigger than here. And this is the 2p orbitals, so it will be in a dumbbell shape, overlapping, because they are sharing. And then over here, so this is sigma bond, this is sigma bond, and this is pi bond. It is okay if it's like overlap here, as long as it is parallel. So the pi bond, and then O1, O2, O3. So see, table 2 shows the molar mass and boiling point of NCl3 and BCl3. So this is it. And then it asked for us to explain the difference in boiling point of the two compounds. So this is how and it's only for 2 marks. So this is how we explain. So NCl3 is a polar molecule and has dipole-dipole forces, while BCl3 is a non-polar molecule and has London dispersion forces between its molecules. And because NCl3 is a polar molecule and has a dipole, BCl3 has the London dispersion. NCl3 has a higher boiling point because the dipole-dipole forces is stronger than London dispersion forces. So this is quite the last question. Question D. Copper Cu is a good electrical conductor, while carbon C in its diamond air loops is a poor electrical conductor. Discuss this statement based on band theory. 2 marks. So we can explain it as copper is a metal while carbon is a non-metal, and then we can draw to explain more. So you can see there is no gap here, whereas there's a large gap here. And then we have to remember to say which one it is. So this one is metal, which is referring to the copper. This is for non-metal, which is referring to the carbon. So there is no band gap between valence band and conduction band in Cu, whereas there is a large gap between valence band and conduction band in C, carbon. Thus, the electrons, they can move freely from valence band to conduction band of Cu to carry electricity, while C does not. Because of a large gap, the electrons of carbon cannot move freely. There is like hurdles here. Whereas here, they can move freely from each other, from the conduction band to the valence band like that. That's all from me. Hope you understand. Thank you.